Yeah, good evening, everyone. Switch on cams. Let's start off. It landed safely. People are blasting bombs near my house. It must have landed safely. So let's start off. Are those cams on? Last thing was 32. So we have a block M here, block 2M here. Find acceleration and tension in the string. Let's get this. Easy one. Yeah, acceleration of both the blocks. What is A, Aryan? You have to give me the value of A now. Okay. Right, Arjun. Yeah, easy stuff. Now, listen, how to do this thing? The general process? No, Aryan. You're messaging something else completely. Well, this is missing. Two people are missing. They went to moon, kya, with the thing? You're supposed to watch it, you're not supposed to go there. People who are missing, join fast. Now, listen, I'll give you a more general solution. Listen carefully here. If this block is M1 and this block is M2, this is also called as Atwood machine, okay? It's a pulley and two block system, no? It's called as Atwood machine. So in some books, you will see this word and you'll get scared. It is nothing but a pulley and this thing. So what are the steps here? Remember last class we wrote here the steps to solve a problem. We still follow the same thing. Choose your system, draw the FBD, assign accelerations, find relation between them, choose your X and Y axis, write the equations and solve. So first thing, choose your system, the two blocks. M, tension, Mg, tension, 2 mg. Now be very careful, things keep it very organized. The forces should be on the body, acceleration should be outside the body. Make sure they're not touching. If this is going down, that should go up because the length of the string is constant. Next thing, force equations. T minus mg is equal to mass into acceleration. Understand what you're writing. T and mg are forces. That should be equal to mass into acceleration. Some people have a habit of writing like this. There are T minus mg minus ma0. Don't do that. Equation wise, you might get the answer, but you will do it wrong. If you are doing that way, please change that way. And here the equations would be T minus 2 mg is equal to 2m into minus a. Up positive, down negative. You're sticking to the convention. You could have simply written 2 mg minus t, but that is okay. So T is equal to mg plus ma. Sorry, m1, m2, na? Why the hell the page turned? So there again, tension m1g, tension m2g, acceleration down, acceleration up. So if someone asks you force acting on the block, it is only T minus m1g. This would be T minus m2g is equal to mass into acceleration. Net force is mass into acceleration. So from here we get T is equal to m1g plus m1a. Take this and substitute here. You end up with m1g plus m1a minus m2g is equal to minus m2a. Bring all a's to one side and that thing to the other side. You get a is equal to m2 minus m1 by m2 plus m1 into g. This is a general formula for two blocks, people. Now, once you got the acceleration, you can put it in any equation. You can put it this thing here. We end up with tension is equal to m1g plus m1a. If you substitute, I know the answer, I'll write it down. You can verify. 2m1 m2g by m1 plus m2. You can derive, you can remember, helps. This is how you do for m1, m2. Now, how do you know, sir, m2 is going down or m1 is going up? We don't know. So it doesn't matter. You choose any direction you want. The science will take care of it. For example, here, if m2 is less than m1, I'll get a negative sign. Negative sign indicates it is not going down, it is going up. Clear? So whenever you have blocks and you don't know how the blocks are going, assume any direction you want. The science will take care of it. You have to choose for one block and the other one will come automatically. I'll just turn the page. So using this formula here, you can finish with the same thing. We get acceleration is equal to 2m minus m by 2m plus m g by 3. You can solve it regularly. Tension will be 4mg by 3. There I solve for variables. Check this out. Play with this. Now there is even a better way to do this thing. Any doubts on this page? But see, this is the general process. Your general process will always work. Sometimes it might be lengthy, but it works. Drawing the FBD, writing the equations and solving. Now, this thing, we can do it in another way. Now, listen to this carefully. This will be quite useful in certain cases. I call this method net force method. You'll again encounter something like this in rotation. What this thing says is acceleration of the body or acceleration of the blocks is net force along the string. So listen carefully to this. Net force along the string by total mass. The only condition is this is valid only if all the blocks have same magnitude of acceleration. Now, what is this method? See, listen carefully. So what I'm suggesting, we have this block M1 here. We have this block M2 here. If you look at the forces acting, this is M2G, which is actually pulling down. This is M1G, which is trying to pull the other way. If you say this is going down, you assume any direction you want, then this has to go up. So what I'm suggesting, can I just make these blocks flat like M2 and M1? And then the same forces will look like this. M2G backward, M1G backward, acceleration and acceleration. Does this make sense? If you just make the whole string straight line, you'll observe the forces along the string will be M2G. So the net force will be M2G minus M1G by total mass. Is this clear? Is this logic making sense? So you're taking forces along the string because only they are responsible for making the acceleration. So here M2G is supporting the motion, M1G is opposing the motion. So it is M2G minus M1G by total mass. Have a look at this. This will actually save you a lot of time for certain models. I'll show you some more examples on this. You could have solved this normally like this. This is same thing. We are eliminating solving the equations actually. Please check. Neil, clear with this? Ali? Arjun?
Yes.
Clear with this? Ritu? Clear? Anika? Aryan? Maulika? Vidyut? Clear? Adrit? Venkatesh? Aditya? Yasha? Clear? Now, can I turn the page? You can put down that if you want. Now let's see some examples on this where this method will shine. So we will call this net force method. So we can have some word to use it for reference. Now see. Now using this method, can you solve this problem? You'll get answers in one step without writing any equations. Let's say this is M, this is 2M. Find the acceleration of the blocks. See, I'll just show you one more example B. Listen. Step one, what you do? Along the string, you want the forces. So here, the mg is pulling it down. Acceleration will be down. Acceleration will be this way. Agreed? Now, can you see this 2mg, what it is doing? The 2mg ka weight is this way, which is balanced by normal reaction. So along the string, what are the forces? So this mg is supporting the motion. So mg, 2mg is not providing any force, so done. By total mass is m plus 2m. G by 3. Easy. That's it. You just take the forces along the string, and all the forces along the string should be equal to, by total mass should give you acceleration. If you want to find tension, then you have to draw an FBD. कोई एक block का FBD draw करो. So this is tension. This is acceleration. T is equal to 2ma. This will be 2mg by 3. But this method will give you accelerations directly. You want tension, you have to draw an FBD. Can you do for C and D? So first choose any block acceleration, doesn't matter. Choose M1 is coming down or M2 is coming down, doesn't matter. And start from there. Try, you got 2 minutes. I hope the B ka example is clear. Someone is confused, please ask. I'll explain again. Please don't hesitate. Get things cleared if you're getting confused somewhere. You can unmute and ask. That will be great. Or feeling shy, just type a message in the chat box. But do get these things cleared. We're going to use this net force method a lot. Saves time from writing equations, nothing much. Any doubts on the B part? How did I choose that? What is the force and all? Mg is supporting the motion. 2m is not doing anything. It is just sitting there and taking acceleration. So mg by total mass. Answers for C. You have to type to the co-host. Maybe you guys are typing to the wrong chat box. I'm not getting any answers. I know it is a little weird to type. See whether you got the same thing. So we are talking along the string. What is this component? M1 G sine theta 1. What is this component? M2 G sine theta 2. I will assume M1 is going down. So if this is down, this is up. So acceleration A will be M1G is supporting the motion. M1G sine theta 1 minus M2G sine theta 2 by total mass. That's it. Single step. Clear? You're getting no need to write equations, nothing, you'll get the answer. But a key problem is both the blocks should have same acceleration. You will see later on when this will not work. What about D? Get it, D is same as C only.
कुछ लोगों को रुलाया, काफी लोगों को
This is capital Mg. I will assume this is going down. So you want forces along the string. This is Mg sine theta. So acceleration will be Mg is supporting the motion. This Mg, small mg sine theta is opposing the acceleration. That's how you have to see. Is the force helping the motion or opposing the motion by total mass? Both are not same m, so capital M and small m. Clear with this? Easy stuff. So you could have done normally, you could have solved this way. Niranjan, Rehan, clear with this? Ronak?
Yes, sir.
Clear, na? Udayan? Clear. Now, where will this method shine? You know, when you have multiple blocks, this method will become super nice. Can I turn the page, everyone? Any doubts on this page, please ask. Anyone not clear with anything in this? Look
Sir,
at this guy.
acceleration and force is in the same direction, therefore we took positive and negative.
Yeah. Basically, mg and a are in the same direction. mg is helping a, right? And this guy is opposing a, na? So subtract. Okay? Look at this guy. There. Find acceleration of the blocks. And tension T. I want you to find this tension. Tension in that string I want. Now, if you want to solve this normally, 6 bodies are there, 6 free body diagrams, 6 equations. It will be a mess. And strings are different. Sabka tension alag hoga. T1, T2, T3, T4. But using this net force method will actually save your time. So these kind of problems, this method is quite useful. Get this thing, find the acceleration of the system. I think that is still fine. And find that tension T in that string, red one. I hope the question was clear. Try, you got a minute or two. I know it is a little bit to type. Don't worry about that. But solve. If you're done with the acceleration, get the tension part. Let me show you in a minute. Another 30 seconds for acceleration. So what is this thing doing exactly? Satellite will go and land and take photo scans. And imagine alien ka photo comes. Aliens are saying hi to this thing. It will be quite interesting. Ali. Yeah, you are right, Ali. You got that right. Aryan, you goofed up, Aryan. You goofed up there. See, the acceleration part. So this thing, first, let the M1G, okay? I will decide, right? Let's say I'll assume it is going this way, okay? You could have assumed that way also, nothing wrong. But so M2 is not having any force. M2 is not supporting anything. M2G is vertical. You need to take forces along the string. Har mg nahi lena hai. This M3G guy is giving M3G sine alpha. M4 is not giving anything. M5 is giving M5G sine beta. And M6 is giving M6G. So if you look at the acceleration, M1G is actually opposing the motion. You should subtract it. So this will be M6G minus M5G sine beta minus M3G sine alpha. Sorry, plus. They are helping the motion. Minus M1G by total mass. That's it. Single line, you'll get the answer. No need to write all the equations and solve. Like I said, it all depends on which side you're taking as positive. I have taken right. If you have taken left, you would have got M1G minus minus minus. Now that the science will take care of it. You don't worry. If numbers are given and if I get this positive, means my direction that I assumed is right. If I got minus, means the direction I assumed is wrong. I have to take reverse. Easy with this? But tension कैसे निकालेंगे? How will I find tension? M3G sin A minus A. ना रे गॉड, यहाँ पे ऊपर का टेंशन भी है ना. M3, when you draw FBD, remember there is this tension here, there's one more tension here. If you just draw M3 FBD, you'll get two tensions, one on the top and one at the bottom. The upper ka tension, I don't know. Think I'll give you a minute more. How to get T? The tension in the middle string. Remember last time when we said, whenever you want to find tension, what are you supposed to do? Cut it there. Wherever you want tension, cut it there. And when you cut it, you get two parts. So I will take this bottom part, okay? You could have taken the upper part also, doesn't matter. Now what are the forces? Tension, agreed? Now if you apply the same method, what are the forces acting? M6G plus M5G. So acceleration will be M6G plus M5G sine beta minus tension, because this tension is opposing the motion. See, that tension you have to forces along the string now. By total mass, what's the total mass now? M6 plus M5 plus M4. Is this making sense? End of the day, the M4 does not know whether it is a string that is pulling or 10 blocks which are pulling it. I don't care. So simplify this, I'll get the tension from here. M4, M5, M6 into acceleration minus, this is minus, M6G plus M5G sine beta, this tension. Easy? Is this logic making sense, everyone? Because if I cut it here, if you ask M4 who is pulling you, it will say the string is pulling this way, opposite to way. Now, that T is created by 10 blocks on the left hand or whatever happens. I don't care. Clear with this? Any doubts on this? So this way I can find tension wherever you want. No? I can cut it anywhere you want. If I ask you find tension here, you cut it here. You want tension here, cut it here. And just take the left part or the right part and solve. Please check. Clear? Is this making sense, everyone? Can I go ahead? Next one. Adrit, got your mistake? Anusha, clear, na? Kartika, Anika, clear? Neil, Ali, got this? Aditya, Rehan? Any doubts? Next one. So there, this is how you use net force method. Saves you a lot of time from writing multiple equations. But like I said, there's only limitation kya hona chahiye? All should have same magnitude of acceleration. If you don't have same acceleration, you can't take out A common. That's the problem. That is all one problem. I kept all that in one problem, 33. So there. Now, when will this method doesn't work? Let's say you have block M. Block 4M. This is 1 meter. Initially, both are at rest. Find the acceleration of the blocks. Now, how do you know you can't use net force method? Tell me one thing. Listen, the moment you see this question, aren't you getting a feeling दोनों का acceleration same नहीं होगा? That much you can see and tell, right? When you see them, you get a feeling like, यार दोनों का acceleration same नहीं है. That's it. If you get that feeling, you don't use net force method. It won't work. Find the acceleration of the blocks. When 4M block hits the ground, it stops. Find the maximum height of M block from the ground. Let's get this. Now, next force method doesn't work. You have to go back to the general process. Draw your FBD, define accelerations, find the constraint, write the equations, solve. Remember, never forget your general method. All the additions that I am teaching, right, are like kind of, I won't say shortcuts, but yeah, it's a general method ka simplifications. Saves you time during an exam. That is right, Anika. Get the second part also. Initially, both the blocks are at the same level. Now, listen, someone got an answer 3g by 2. First thing, you can see this and say it's a blunder. You're getting, it is important to know what is a blunder. Why? Think about it. If I take a block and leave it, what is the acceleration g, right? मतलब तो कुछ भी करो, no matter how much mass you take, you will get answer g. Now, when you have all the strings and everything connected, do you still think it will fall with g? So there, that is how you know when you see an answer, it's a blunder. And it is very important, huh? Exam when you get options, you can eliminate them. So when you have strings and blocks connected, there is no way you will get an acceleration greater than or equal to g. फिर भी g भी आ सकता है, but you can't greater than g. That is how you know it's a blunder. Udyan, I think your answer is wrong. Yasha, you're wrong. Anusha, you got it, but which block is okay? You got it. Anika got it. We have two right answers so far. Nah, right, that's wrong, Anika. Second part is wrong. Arjun, that is wrong. Aditya, right. Right, Yasha. Nah, wrong, Aryan. Right, Mehan. Let's see. Step 1. Choose a system, draw the FBD. Tension, mg. This will be tension. So this will be 2t. Step 2, define your accelerations. So let this guy be A1. Let this guy be A2. Sir, how do you know it is like this? I don't know. So assume A1, A2. You want A1, A2, दोनों भी ऊपर ले लो, चलेगा, कुछ problem नहीं है. Step 2, find the relation between them using constraints. See, I'm teaching you very step by step. That is how you're supposed to learn. Because once you learn like that, then in the exam, you can actually skip the steps and solve the problem faster. When you learn slowly, you will get it better. So at least when you're practicing, make sure to do it detailed. T into A1 plus 2t into minus A2. Now, once you become strong, then you can start ignoring steps and solve. But initially, if you're getting wrong answers, especially if you're struggling with NLN, do it properly. This is your first equation. Then resolve the forces vertically, horizontally, and solve. So equation for the block T minus mg. So you know what is the meaning of this? A1 is 2A2. So T mg, if I assume this acceleration, if I assume this is going down with A, meaning this guy will go up with 2A. Okay, I just changed it from A1, A2 to A into A. Write the equation. T minus mg is equal to m into 2a. 4 mg minus 2t is equal to 4m into a. I hope you're getting. I took down positive now. Or you could have just stuck to your general convention. 2t minus 4 mg is 4m into minus a. Take t from here and dump it in this. So 2 mg plus 2ma minus 4 mg is equal to minus 4 ma. Bring all a's to one side, 8 ma. Bring all mg's to one side, 2 mg. A is equal to g by 4. Check. That means this guy, the small block is going down with g by 4, big block, and this guy is going with g by 2 upward. Check the steps. Wrong, Ronak, Yasha, wrong, Anusha, wrong. I want from the ground level. Hope you're calculating from there. The question is find the maximum height from the ground. That's the second part. Got a minute, try. Nee, Ronak, that is wrong. Second part is a good one. Wrong, Yasha.
So the question.
Question, yes. I hope everyone got the acceleration part. Free body diagram, constant equation, equations, and solve. Can I turn the page? Questions are clear? No, Aditya, that is wrong. Think for a minute, then I'll give you a hint. See, when 4m stops, m need not stop. When 4m stops, m need not stop. Now, if you understand the meaning of the statement, 30 seconds more. Now try.
So can you show the question? When 4m hits the ground, why should m stop? The m is going up, isn't it? It will try to go up. What will happen? String will become loose now. When 4m hits the ground, m will continue to move up. And the string becomes slack. Because strings cannot push. It behaves like a vertical projectile. So initially the scenario when the 4m hits the ground, now see, this was the initial level. This was 1 meter. And we know whenever 4m is going with acceleration a, m is going with double the acceleration. So this is 2 meters. But the catch is at this point, the velocity v, it does not have zero velocity. It has still some velocity. So, and what is this acceleration here? We just now calculated g by 2.
So the block started from here to here. Using kinematics, v square minus u square is 2as. V square u is 0, 2, acceleration is g by 2, and s is 2 meter. We get v square is equal to 20. So from here, what will happen? The block won't stop. The diagram becomes like this. The string will become loose like this, and the block starts flying in the air. So it will go up and come down. How much is this thing? V square by 2g h max. And that comes out to be 20 by 20, 1 meter. So the block will reach a total height of how much? 1 meter more. So total height will be initially 1 meter, then it went 2 meter, then it started flying up for 1 meter. 4 meter is the answer. Right, Ritu. Is this clear, everyone? Did you get the catch? When the forum hits the ground, agreed, it has gone 2 meters up, initially 1 meter to 3 meter, but it won't stop there. It will continue to go up like a projectile, the string becomes loose.
Sir, it will. How did the initial 1 meter come? I didn't understand.
Because that was given. Because that was given in the question.
Okay, from the ground. Okay.
Yeah. Question पूछ जाता from the ground. You can't now say, you can't change the answer, sir. I did it from the initial level. That's why I said the answer is from the ground. Okay. Clear with this? So there, be careful. Kinematics and NLM. So the blocks won't stop just because other ones stop. The string becomes slack. Next one. Turn in the page. Any doubt so far? Niranjan, clear, na? Ali? Maulika, all clear so far? Kesha, got the answer? Abhinav, getting this?
Yeah.
You should type the answer, Ritu. Maximum what will happen? You'll be wrong. Big deal. Next one. Three M, 2M, and M. Find acceleration of 3M block. Yeah, you can actually find acceleration of all the blocks, but okay. Let's get this. I'm sure you're getting a strong feeling it is 0. You'll get a -1 for that. If you had got that feeling. Try. Standard process. General method will give you the answer, but it becomes slightly lengthy. I'll show you general method, then I'll show you a faster way to do this. Step 1, free body diagram. Let this be T, T, mg, 2 mg. This is 2T. No, that is wrong. This is 2T. This is 3 mg. Now listen here. You must have goofing up the accelerations. If this is A1, this is A2, this is A3. I don't know acceleration of any one of them. In case you have done this, sir, this is A1, this is A1. That's a blunder. Pulley is not at rest. Pulley bhi move kar raha hai yahan pe. There is no guarantee M and 2M will have equal and opposite accelerations because the pulley is also moving. Please check. This is your first FBD and the accelerations. Anyone not convinced with this, please ask. This is the first thing most people goof up. They think M and 2M are going in opposite directions with equal acceleration. That is not true. Only if the pulley is at rest, you can do that. The pulley is not at rest here. You don't know. Then constraint equation. 2T minus A3 plus T into A2 plus T into A1 is 0. So A1 plus A2 is 2A3. You can ask me, sir, how do you know A3 is going down? I don't know. How do you know A1 is going up? I don't know. You assume whatever direction you want. Farak nahi padega. You can take A1, A2, A3 all down also, all up also. The science will take care of it. You don't worry about that. You don't take the tension which is heavy, which is going up. Don't do that. Just take A1, A2, A3. Let the answers take care of it. Equation 1. Now, equations for the first block. T minus 2 mg is equal to mass into acceleration, A1. So A1 will be T by m minus g. Second block, T minus 2 mg is equal to 2m A2. Acceleration T by 2m minus g. Third block, 2T minus 3 mg is 3m minus A3. We get A3 is equal to g minus 2T by 3m. Why am I doing this? For A1, A2, A3, the common term is T. So from there, I got an idea. If I can take all these three and put in this one equation, I can eliminate A1, A2, A3, I'll get T directly. Put all these three guys in that equation there. You end up with T by m minus g plus T by 2m minus g is equal to 2 times g minus 2T by 3m. Bring all T's to one side. So take out T by m common. 1 plus half plus 4 by 3. Bring all G's to one side, 4G. This thing would be 24 mg by 17. I just did this today morning, so I know. Check it out. That's your tension. Once you got the tension, put it back here. You want A1, A2, A3, you can get whatever you want. You want A3 now? So A3 is G minus 2T by 3m. Substitute the T here. G minus 2 by 3m, 24 mg by 17. Mm goes off. You get G by 17. That's your acceleration A3. You want A2, put it there. You want A1, put it there. You get whatever you want. This is how you solve with the general method. Free body, constant equation, force equation, solve. And the general theme is eliminate A1, A2, A3 in one go. You'll get everything in T terms. T aa jayega, then put T back, you'll get whatever acceleration you want. This is how you handle this. But time consuming. You have to solve 4 equations. Let me show you a faster way. But you should know your general method. Remember that. Just don't be happy with the shortcut every time. Sometimes you might not remember. Sometimes you might goof up. Sometimes it might not work. So check this out. Four equations. Some people ask, sir, why can't I take this as one block? Remember, if 2 blocks have to be system, what is the condition? They should have same acceleration, same magnitude, same direction. Here, both are going up and down. So there is no guarantee they will go in the same direction, same acceleration. Clear? Check it out. Can I turn the page? Any doubts? Anyone? Anyone not clear with the steps? Standard. There's nothing. The brute force solving it. Once you got the 4 equations, physics, the job is done. Clear? Now, how to do this faster? Fully equivalent. So when you take this block here, M1 and M2, if this was tension here, if there's a tension 2T. Yeah, we just now calculated Atwood machine mein tension is 2M1 M2 G by M1 plus M2. That means if you want to replace this whole setup with a block whose mass is M equivalent, so tension here also should be equal to 2T. So 2T should be equal to M equivalent into G. So this would be 4M1 M2 G by M1 plus M2. So we get the mass equivalent of this pulley is 4 times M1 M2 by M1 plus M2, or 4 by M equivalent is 1 by M1 plus 1 by M2. You can replace that entire pulley with that thing with this M equivalent mass. And the best part, this is valid even if the pulley accelerates. We can prove that, but you can do that and check it out. But I proved it. It is what works. Valid even if pulley is moving. Now, example, the previous problem. Now see how fast it becomes. This is 3M. This is 2M. This is M. So you are trying to replace this whole thing with one mass. So M equivalent will be 4, 2M, M by 3M. That becomes 8M by 3. So you can replace this entire block with 2 blocks of mass 3M and 8M by 3. 3mg, 8mg by 3. Acceleration, acceleration. Net force method. Acceleration is equal to 3mg minus 8mg by 3 by total mass 3m plus 8m by 3. Solve this, you'll get G by 17. Check it out. The problem which we did just now, if you use this pulley equivalent, you get the answer in pretty fast. You can avoid all those steps. And the whole logic is, because for the ceiling, right, I don't care whether you're keeping 10 pulleys or 2 blocks or 1 block. The ceiling will think only one thing. मेरा पास tension 2T होना चाहिए, which is 4m1, m2j, m1 plus m2. Whoever gives it, I don't care. It is all same for me. So the ceiling will start thinking, or the pulley, you can replace the whole thing. The string will think it is as good as a block of this. So m plus 2m is not 3m here. So this whole pulley system is acting like 8m by 3. That's why 3m is not at rest. Have a look at this. Quite useful. Saves you a lot of time. So be careful. Net force method is a different technique. Pulley equivalent is a different technique. The general method always works. These are just additional techniques, from the general method, which we're actually using the general method only to get some techniques here. So if you remember them, you'll say much easy, save time. Have a look at this. You can note down that formula there. Let's do some problems on this. Anyone not convinced with this, not clear with this, please ask. Clear? Can I go ahead? Turn in the page. Neil, clear na so far? Vartika, all clear? Alaksh, Niranjan, clear? Anusha, clear? Let's see a problem. One kg, 2 kg, 3 kg, 4 kg. Find acceleration of the blocks. All 4 blocks. How do this? Venkatesh, are you there?
Yes.
Do adjust your camera. I can't see you. Yeah, and your fan is not going or rotating also. And that is fine. Yeah. Hope everyone has given the test. I accidentally kept 11 a.m. instead of 11 p.m. as deadline, so expire हो गया था. I did extend the test till tomorrow morning, so in case someone wants to give, you can give it. How do you do this? Let's replace them. I'll replace this with M equivalent, which is 4 into 3 into 4 by 7. Numbers are bad. 48 by 7. This should be M equivalent 4 into 1 into 2 by 3, 8 by 3. Let me just write the equations. Numbers I could have given better. So this whole thing becomes something like 8 by 3 kg. And this whole thing becomes 48 by 7 kg. And then I can find the tension here, T and T. From the Atwood machine ka formula, I know tension T is equal to 2 M1 M2 by M1 plus M2G. I can get the tensions directly. Let's call this guy M1, M2, and let's call this guy M1. I will leave the working to you. And once you got that, you are done. So this pulley which we have, what you have done is you have taken this point as tension T. So meaning at this point, the tension will be T by 2, T by 2, T by 2, T by 2. Basically calculate the T by 2 value. You want acceleration. So for the 1 kg, tension T by 2, weight 10 Newton, let the acceleration be A1. So T by 2 minus 10 is equal to 1 into A1. Substitute T by 2 here, A1 aa jayega. You want 2 kg ka acceleration? Tension T by 2, 20 Newton. Just assume any direction you want. Science will take care of it. T by 2 minus 20 is equal to 2A2. You get A2 from here. Tension is T by 2, 30. Acceleration is A3. I know someone has to go down, so the science will take care of it. T by 2 minus 30 is 3A3. You want acceleration of the 4 kg? This is T by 2 by 40 and let it be A4. T by 2 minus 40 is 4A4. Please check. I'm using multiple concepts here. One is the pulley equivalent, then I'm using net force, Atwood machine ka tension ka formula. Once I got tension, I know you took the major string ka tension as T, this string as T. So the niche ka strings will be T by 2, T by 2, T by 2. Once I know the tension, it is done. T by 2 minus mg is equal to ma. Whichever block acceleration you want, you can find. So I know numbers are a little bad, so I will leave the working to check. But I hope you got the process. Tension is 3.84 G. Okay, fine, that's okay. It's not such a great number, but okay. But look at the method, everyone. Numbers, I trust you. You are pretty good at divisions, multiplications, and additions and subtractions. I hope. So yeah, near to 4. Do check it out. So this is how you can do. Saves you time, or else you have to write A1, A2, A3, A4, constant equation, 4 FBDs, 4 equations, total 5 equations. They're looking quite lengthy. Next one is even better than this. Let's see the next one. But any doubts on this? First, let me ask me if you're confused here. Clear? Next one. Can I go ahead? Anyone not convinced with anything here? Please ask. Ali, clear, na? Abhinav? Got this? Adrit? Ritu? Next one. Let's see how many of you will get this. We have a block of mass m. We have a block of mass m. We have a block of mass m and infinity. Ta-da! Find the acceleration of this block. System never ends. How do we do this? So for you guys, I'll draw one more pulley. The system never stops. Infinite pulleys. Find acceleration of the top block A. All are same mass. Try. अरे अरे कैसा होगा अरे जी I know what you did. तो पूरा sum of infinite terms ले लिया क्या? 2g/3 ना रे Niranjan, that's also wrong. I'll give you a hint. This problem is inspired by y is equal to root over x plus so on till infinity. Done this problem?
Quadratic. Yes, sir.
So abhi karo. This is a hint for this problem. This problem is actually inspired by this equation. अभी सोचो क्या करेंगे.
Quadratic is not good.
बस हो गया इतना ही. There is no more hint. If you can figure out the hint, great. That's why it's called a hint. अभी मैं पूरा problem explain करूँ क्या? Try कर. You have 1 or 2 minutes, then I'll show you anyway. Where am I running away? बस hint वही होता है. Y is root over x plus x. So how the hell do you use that in this question? Maybe you figure it out. Try. 2 minutes. This is a question where it is tough to think but easy to solve. Try. I'll just get some water and come. No, Malika, that's not the answer. Just get it right. G by 5. Ah, Adrit, you got it right. It's not G by 5. Let's see how to do this. So let this whole thing, infinity thing, let this whole thing be x. I don't know what is that x, but the whole thing is x. Okay. Now, if I just remove one block, and if I try to write this whole thing, this is also x. Does that make sense? Because if you just remove one block, you can still see it is infinity, right? So that means I can replace this whole setup like this. Fully, this side is m, and this side is m, and that whole green color ka branch, I'll put in green color, is x. But we know already this whole thing is again x. Are you getting it? So what is the Pulley equivalent of this system? The Pulley equivalent of this system is 4m x by m plus x. That should be equal to x. Therefore, x is equal to 3m. Is this making sense? Isn't that what you do in this equation? Y is equal to root over x plus root over x. You'll say y is equal to root over x plus y. And you try to solve. Please check the logic there. Once you have done that, you are done. This will be m and this will be 3m. And net force method, 3mg, mg, acceleration and acceleration. So A is equal to 3mg minus mg by 3m plus m, which is g by 2. Check. They did the same. Okay. There, you should know the Pulley equivalent method ka that thing. Because if you try to write equations, you'll get infinite equations, and you'll get infinite GPs. You might be able to figure it out also, but it goes quite lengthy. Check this out, infinite pulleys. Once you figure that out, you can see that it's so easy to solve actually. But getting that initial idea is the headache. Please check. Anyone not clear with this, please ask. Others, do keep your cams on. Clear? How will you find acceleration of this block? क्या करना था? Just tell me a logic. Anyone? If they ask you acceleration of this block, second layer, what is the logic? That will be pain, Ray. देखो ना, from here, can I find the tension T? So I'll get this tension T. तो यहाँ पे tension कितना होगा? T by 2 ना? T by 2 minus mg is equal to ma. Are you getting it? If you want the next block, T by 4 minus mg is equal to ma. Next block, T by 8 minus mg is equal to ma, and so on. Are you getting this? So you can just find the tension in the upper string, which you will get from here. T is to m1, m2, m1 plus m2g. And then the tension keeps on decreasing half. So any block you want, find the tension and finish it off. Are you clear? That will be a good question. I'll just add it there. So if this was T, this would be T by 2. So you can find from there. And here the tension would be 2m, 3m by 4mg. Clear? Great. Can I turn the page? Any doubts on this? It's a good one. Next one. Now, a more generalized method and useful one. We are going to see this again in simple harmonic motion. Now, consider if you have n strings.
Sir, I had a doubt in the previous question.
No.
Sir, I tried it by considering the third pulley and so onwards the entire system, and then I used the mass equivalent method. So I got
What did you do?
16
No,
by
no.
5 instead of 3.
What did you do? This whole thing you took it as what?
I took that as m plus n plus n plus n because that will get cancelled in the 4m into.
No, you can't do that. How can you take m plus n plus n plus n? You can't do that. You can't. अगर ऐसा करने तो why are you not doing it from here only m plus n plus n plus n?
So no.
Q? Why is this so special? You are just being a racist with the third pulley. If the pulleys have feelings, they will get hurt. Clear? There is always like that. Think, if you can do it third, why are you not doing it the second pulley then? No? Now, listen, this is a more generalized method. Consider we have n strings with n different blocks. Now, see, this is really not that important derivation, but the result is kind of useful. So let's say C1T is the tension of the first block. And C1 is the coefficient of the tension. So if you say CNT, this will be the tension of the nth block. So C1, C2, Cn are the coefficients. Mn is the mass of nth block. Meaning, let's say you have a system with n blocks and n different strings. And An is the acceleration of the nth block. Now, using the power method, what is power method? Tension into acceleration. The product is this thing. C1T, A1, C2T, A2, so on till CNT, An is 0. Be careful. You can use this only when only strings are present. And the angle between the tension and acceleration should not change. And then if you choose any one block, the forces will be Cn, Tn, Cnt, Mng, and acceleration An. We get Cnt minus Mng is equal to Mnan. From here you can get An, and that will be Cnt by M minus G. So you can take this and dump it in that equation. If you dump it in that equation, you will get C1T. So that will be C1T by M minus G plus C2T. I'll show the previous page. C2T T by M minus G. So on. CNT by M minus C. Again, derivation is really not that important. 0. See what I did. So A1 will be C1T by Mg. I kept it here. A2 will be C2T M by G. I kept it here. C3, C4, so on. I just substituted everything there. And from this, if you take out the T common, you will end up with T square will be C1 square by M1, C2 square by M2, so on till Cn square by Mn minus Gt by C1 plus C2 plus so on till Cn is 0. So from here, if you take out T common, you end up with sigma Ci square by Mi by sigma Ci into G. So this is nothing but C1 square by M1 plus C2 square by M2 plus so on till Cn square by Mn into G by C1 plus C2 plus I wrote wrong. Sigma Ci by G by sigma Ci square by Mi. Reverse लिखा मैंने. So this is nothing but C1 plus C2 plus so on till Cn. Now if you can remember this, great. Or else always a general method works. But I'll show you where this becomes pretty useful when you have a very complex pulleys and strings and all nonsense. This helps. This is the tension in the string. So which tension is this? This is the tension in any string of your choice. You start with T at some place. Tension in any string of our choice. You assume some point is T and start the problem from there. T is the tension in any string that we started with. So using this, we can actually find the tensions there. So I'll just write this thing once more. So this can be written as sigma coefficient of tensions by sigma coefficient of tension square by mass. This gives you the tension in any string. Let me show an example, you will understand. Main thing, use this only if strings are present, okay? If normal reactions all are pushing, don't do that. Use this if only tensions are present and gravity is fine. You can note down that formula there, note it down. You won't remember that. Let me show some examples on that, how to do. How did I get third step where I use sigma? Yeah. Previous page. Nee, this only, right? Summa na? That is sigma, right? Summation of this thing. Actually, kya hai na? I should have written this first and then should have written this next. Reverse lega maine. Na? C1 plus C2 plus C3 sigma Ci na? Got it? First actually ye likhna chahiye tha. I should have written this. Then this will become this. I wrote reverse. I is the ith block. Computer programming we do na for I loop, for I is equal to 1 to 10. So C1, C2, C3, C4, that I is changing. So that I ka value is going from 1 to n. Na? C is the coefficient of tension. Dekha na starting mein dekho C1, C2, Cn. So C is the coefficients of the tensions. I'll give an example. You'll understand. I know the formula looks pretty vague. समझ में नहीं आएगा if you see like this. Let me show an example and then we'll get back to the formula. I'm sure you'll understand. Clear? Show an example. Can I go ahead? Next one, see. Example. Let's do our problem which we did right now. This one. So this is 3m. This is 2m and this is m. Okay, this is how you do this thing. Step 1, choose any tension. Let this be T. So if this is T, this will be T by 2 and T by 2. Agreed? ये तो करना था. Next thing, you want to find tension. So the formula tension T is equal to sigma coefficients of the tension by sigma coefficients of the square by mi into g. So first block का coefficient कितना था? Look at the coefficients of this tension. This is 1T. This is half. So coefficients will be 1 plus half into g. Are you getting? C is the coefficient of tension. So इसका coefficient half था. This coefficient is also half. By coefficient of the first tension is 1, mass is 3m. Second is half, mass is 2m. The third is half, mass is m. So that would be 2g by, this would be 1 by 3 plus 3 by 4. M will go up. That will be 24 mg by 4 plus, I goofed up somewhere. Where did I goof up? Oh, sorry, square है ना वो. Square था वो. So 1 square by 3m plus 1 by 2 square by 2m by 1 by 2 square by m. So that would be 2g. M will go up by 1 by 3 plus 1 by 8 plus 1 by 4. That would be 2 mg by 1 by 3 plus this thing is 3 by 8. That would be 48 mg by 8 plus 9, 17. This is the tension in the string. एक बार tension आ गया. Tension 3 mg. Acceleration 3 mg minus 48 mg by 17 is equal to 3m a3. You get a3 is equal to g by 17. Check. The good thing about this, you'll get answers. Bad thing about this, you won't understand what the hell is happening with the problem. You lose all information, what is happening, constant, instant, sub included. You don't even, other than putting the tension coefficients and all, you will lose everything there. There is no information, you won't understand how to drive BD anything. That is the reason I taught this in the last. You will get answers from here, but you will lose all general stuff. So you can find tension in any string. You could have chosen this point as T, okay? If you have taken this as T, this will be 2T, na? Then the coefficient will be 2. Coefficients will be 2, 1, 1. So put it in the formula appropriately, you'll get the answer. So you have to choose a tension T in any string and start from there. You will get the tension value. Have a look at the example. Let me give you a problem like this, you can try. So basically this will give you tension in any string you want. Is this clear? Let's see a question. Can I turn the page? See.
Sir, can you go back for a moment? Yes, sir. Thank you.
Now, Zik, I just kept something weird here. And if they ask you find the acceleration of this block, now it looks so confusing actually. What everything is moving, I can actually make it more messy, but I'm unable to draw. But you got the idea. You take 10 pulleys, 10 strings, you do whatever nonsense it is. Question pucha, find the acceleration of that block. Nee, wait, this will go wrong actually. This will go wrong, don't do that. Yeah, better. Let's get this thing. That will be T0 actually. That whole thing will actually fall with G acceleration. That is wrong. I'll show you that also. Let's get this thing. Find acceleration of this block. Try. Others, keep your cams on. Start like this. Let this tension be T. This will be 2T. This also will be T. This will be 2T. So T will be coefficient of tension. Iska coefficient is 1. Iska coefficient is 2. Iska coefficient is 1. Iska coefficient is 2. Add all the coefficients 1 plus 2 plus 1 plus 2 into G by coefficient square 1 square by M, 2 square by M, 1 square by 2M, and 2 square by M. So that would be 6G, 6mg by 1 plus 4 plus half plus 4. This would be 12mg by, how much is that? 9 to 18, 19. Higher tension, 19 mg by this thing. Did I go for somewhere? 9 plus 8, 19. Yeah. So then, ho gaya, tension aa gaya T. So just write an FBD mg acceleration. T minus mg is equal to ma. So 12 mg by 19 minus mg is ma. So I get A is equal to minus 7g by 19. Minus indicates it's not going up, it is coming down. Easy? This will give you answers. No constraint, force, FBT, kuch bhi nahi, answers aa jayega. And that's why I don't like this. But again, end of the day, exam mein what matters is marks. So you get something pretty complex, you are unable to understand what the hell is happening, you'll get answers. That way, learn both. You should know both. Because every time this won't work, this will fail, you know, when if there are normal reactions and all, abhi wo bhi dekhenge ek do. Main thing is actually remembering is not a problem. Huh? Ratta marna acha hai, but when you understand what you're doing, if you just by heart everything without understanding why you're doing what you're doing, then you'll become like, you know, wo 3 dates mein hota hai na chatur jaisa. Problem is that people think ratta marna bad hai. No, it's not bad. It is very important. You won't get speed. But you should understand when to use, when not to use, what to do, and what conditions you can use that formulas. But all clear with this? The previous thing which we got, let me show you that also. Can I turn the page? Any doubts on this? It is just substituting the coefficients in the formula. This is the question I gave now. Let's see, you get something interesting here. Find this tension here. You actually get an inconsistency here. See what happens. I'll show you. When you say this is tension T, this will be T by 2. This is T by 2 and this is T by 2. But this is also T. This is also T. Then this will be 2T. Can you see the inconsistency here? Here we are getting 2T equal to T by 2 plus T by 2. Wrong, no? It can happen. You know, there's a possibility. Hai. When this will happen, you know, 2T is equal to T, T is 0. This is the only possibility, isn't it? So this is inconsistent. Matlab, when you have a system like this, tension is 0. Since tension is 0, the strings, all strings are loose. All blocks will fall with G. So it is as good as not connecting any strings. Clear? So you will get an inconsistency like this. When you get an inconsistency, the only way to do is that tension is 0. Strings have become slack. That's what it's trying to tell you. So before using the formula only, na, you'll understand. When you try to find the tensions T2 by 2, you'll understand you get stuck somewhere. Clear with this? Any doubts on this? Please ask. Any doubts so far? Can I go ahead? Now you are going ahead from police से blocks also. अभी देखो यहाँ पे whatever I taught you, everything will not work. Nothing will work. Net force method, pulley equivalent, this tension का thing, nothing will work. All surfaces are smooth. Find acceleration of the blocks. Same thing. This you can try as a homework. You have, if you remember, you have done this in constraints. Idea is the same behind them. You have to go back to the general method. Draw the FBD, define accelerations, find the relation between them, write equations, solve. Or general method will never betray you. You'll always get it. Get this thing. Remember, ये दोनों किया था हमने constraints में. Let's get this. Finish off. Last one for the day.
Sir, what we have to find?
Acceleration of the blocks. Find the acceleration of the blocks. Everyone should try. Others do keep your cams on. The next week test will be online tomorrow night. It will be on laws of motion. It will be simply on constraints and the basic equations. Whatever I taught you today, that level won't be there. 2G by 5, 4G by Anika, that is wrong. Forgot. Remember, block M का दो acceleration होता है, horizontal भी होता है, vertical भी होता है. You forgot constraints. Let me show you that problem. Maybe that guys will click you. देखो इसका acceleration. This is the third time I did. This was the velocity, na? Remember? It will have a horizontal and vertical. Don't forget page 38. That's where we did the constraints. Step 1, draw the FBD. And I taught you how to draw the FBD of the same problem. Huh? Tension, tension, normal reaction, tension. Your own weight mg, the n ground. These are all the forces on the small block. Tension, small mg, and normal reaction. Assume the big block is going with A horizontal. This will go with A vertically and 2A downward. That comes from constraints. Next thing, force equations. 2 times tension minus n is equal to mass into acceleration. हो गया, एक ही equation था horizontal. इसके लिए n is equal to small m into A. Vertically, T minus mg is equal to m into minus 2A. 3 equations. Take T from here, n from here, dump it in this. 2 mg minus 2ma minus ma is capital Ma. Bring all a's to one side. You end up with 2 mg by m plus 5 small m. That is right. 2 ma, 5 ma. Huh, that looks right. That's your answer. Check. Got it? So the small block acceleration is, so acceleration of the small block will be a I cap minus 2a j cap. So it's not a single acceleration. Is my calculations right or did I goof up somewhere? Why am I feeling like goofed up? Looks right only. 2mg, 2. Have a look at this. All clear with this? Yeah, the same only. I think it is right only. देखो अभी इसमें that all that methods I taught you, nothing will work. Now make sure to try all these things at home. Today I taught you a lot of different things. Pulley equivalent, infinite pulleys, all that stuff. So I think we did around 7-8 problems. So today, tomorrow, maximum. Ideally speaking, today if it will be better 10 o'clock, 10:30. Take out these notes and each and every question try to do them again, or tomorrow at least. Getting it again. I'm telling you, I'm repeating this every time like a broken tape recorder. Whatever we do in the class, not only physics, maths, physics, chemistry, you are supposed to do it within 24 hours. You're supposed to take that and resolve on your own. Resolve, padna nahi hai, not like a novel. Don't do that. Trust me, if you do this, it will help you a lot. You will be way ahead of many people who are preparing for JEE. This simple thing most people don't do. Because if you see the same notes after 1 week, if you open this after 1 week, you will understand everything, but you will feel like, "Arey yaar, kuch to missing hai." So the same revision, which will take half an hour if you do tomorrow, will take 2 hours after 1 week. You are literally wasting 1.5 hours unnecessarily. So please make sure to go through the entire thing, do them again on your own. Right? We have done most of it, meaning you can start doing your PACE booklet, you can do HCV, or you can start doing my booklet. Next class, mostly we'll wrap up most of it. Ho jayega. Maybe pseudo force might get left over. So on Friday, we will wrap up most of the chapter, and next week we will start with friction. A little bit might be left over that we will do next Wednesday, and we'll start off friction next week. Like I said, the most important thing in the chapter was constraints and FPD. Once you got this, everything else was the general method only. But I'm teaching you some additional stuff so that you can save time. Okay, so with that, we'll wrap up for the